All right, so we are Team Six. We are predicting city bike trips in New York City using forecast data.
All right. So, as Lucas just said, we're checking city bike daily ridership forecasting using weather data. And New York City city bike trip demand varies significantly day to day, making it difficult for analysts to anticipate short-term ridership levels and demand trends. Weather conditions influence city bike usage, but trip data and weather data exist in separate systems and they're not really aligned for demand analysis. And so the lack of a time aligned data set limits analysts' abilities to assess how forecasted weather could affect city bike ridership.
So I'm going to talk a little bit about our architecture. We have two main components to it. We have a historical section and a real time. So the historical will deal with getting all the data that we need to properly train our model. And the real time will deal with the streaming new predictions and putting them in the dashboard. So we have a project bucket inside of our project where we create two folders. We create a weather and a city bike folder. The city bike folder we put the data into by visiting city by New York City City Bike's website with downloadable CSVs. They upload monthly and yearly CSVs for rider trip data in New York City. And so unfortunately the main way that you do that is you just have to go to their website and download it and manually upload it. But that's how we get the New York City City Bike data. And then for the weather data, we go to we have a official collab notebook for this project that's in the GitHub repo. But inside that notebook, there are two open media APIs. There's a historical one and a real-time one. And so for calling historical data, we call the historical open media API for all of the 2022, 2023, and 2024 daily forecasts. And then it creates a bunch of monthly files local in the notebook. And we use the gsutil function to push all of those files into our weather folder. And so we have two databases within BigQuery. We have one for raw data and one for curated. And so what we do is we take the data, the raw weather forecast data, and we create a raw forecast table, or sorry, we create a raw weather data table inside of BigQuery that has all of the data, all the raw data combined for weather, and we do the same thing as well for City Bike, so we can get all of them, each of them like all in their own fully combined separate tables. We then take each of those tables and we curate them by dropping a lot of the columns and stuff that we don't care about. The things that we keep for the city bike are the total trips, the member trips, and the casual trips for each day, the total count for each day. And then for the weather, we keep min and max temp, we keep the date, we keep precipitation, and then also wind speed. And so finally, once we have both these tables like curated how we want them to, we combine them into our bike weather daily table, which is our final curated table that has the combination of trip data and once again the temperature, the precipitation, and the wind metrics. And then finally, we go and we take that table and we feed it to our ML model to train our model to predict future trips, casual and member trips, and total trips based off of this historical weather forecast data. And so for a real-time architecture, we have a Cloud Run function called OpenMedio. So what OpenMedio does is it will call the real-time OpenMedio API to get the forecast for the next 7 days. So we pick 7 days because short forecasting is important, and especially since forecasting changes a lot, forecasting really long into the future isn't super applicable when it's almost always certainly going to change, and sometimes radically between the time when you're looking at it and in a couple days from now. But then we also have a cloud scheduler, which we set to call the Cloud Run function every 1 minute. Now, for this application, calling the API every minute isn't necessary because forecast data, isn't really updating every minute, right? But it's more so that it was just new. It's something that we haven't done before, and so we wanted to play around with it and try to, learn how that works. And so that's the approach that we took for this. But our Cloud Run function publishes the JSON messages from the API. So the data, the temperature, the precipitation, and the wind speeds. And so it puts that into our pub sub, which will then end up in our data flow job. And then we stream it exactly once to our weather forecast stream table in our raw database in BigQuery, which is essentially, once again, a fully combined table of all of the live streaming forecast data. And so what we do is we perform feature engineering on that table when we bring it when we turn it into a curated table, we perform feature engineering. So things like month, which is 1 to 12. So like January, if the date's in January, then the month feature receives a 1. If it's February, it's 2, and just counts up from there. Date of week is also 1. So it takes what the date of the week is and then assigns a number between 1 and 7 based off that. So we put 1 as Sunday, like the first day of the week, and we put 7 as Saturday, the last day of the week. And then finally, we have an engineered feature called is weekend. So it's binary. It's 1 if the date falls on a weekend, and it's 0 otherwise. And so we use these engineered features plus the raw data. And so we take that and we take the most recent ingested 7-day forecast, and we put that into our ML model, and it gives us scored predictions for the predicted amount of trips of casual trips, member trips, and total trips for the next 7 days. And it puts into our trips forecast table, and every time that it runs, it refreshes that table so that we only have the newest 7-day predicted forecast. And then finally, we can use that to we can access that through Looker Studio in our dashboard and create a real-time dashboard that updates. So just for some of the pipeline automation stuff, you'll see this directly more when we go through and we do the full end-to-end demo. But this is our Cloud Run function. It's called Open Media. Um, and this is what calls the API for the 7-day forecast. Specifically, it calls for the 7-day forecast in New York City because that's where our city bike data is at. And then you can see our cloud scheduler called Open Media every minute, which literally just does that. It just runs our Open Media cloud function every 60 seconds. And then finally, you can see our data flow in the top right where we take the JSON messages from PubSub and we finally put them out into our raw table in our database. So for these model results, to kind of help you interpret them, our performance for our member model, or sorry, let me back up. We created 2 models for this. We created one model that would predict the number of member trips taken on each given day, given the forecast data. And then we created one that would predict the number of casual trips based off the forecast data. And then we combine the predicted number of trips from both to give our final predicted trip count. But the performance for these different models varies. So our member model has about a 75% accuracy uh, when using that forecast data, while our casual trip forecast model has about an 80% accuracy. We can do a lot of things to improve the accuracy moving forward with this. The immediate ones that come to mind is using stuff beyond just precipitation, but also potentially snow, hail, and then also looking at some more definitive stuff in regards to the rides, like what type of ride. For example, there's regular bikes and electric bikes, so kind of understanding more in detail which type of transportation method is favored as well based off the based off the forecasted weather.
Okay, so now we'll cover some of the dashboards that we have. So starting off with the historical dashboard, there's three graphs as you can see. So the top graph covers the daily trips from 2022 to 2024. And then as you can see, the blue line means total trips, the purple line means member trips, and the orange line means casual trips. And if you were to hover over any of a specific day on this graph, you could see what you do at the top right. So you would see the exact number of trips taken on that day. And in this way, you can kind of see patterns on trip usage or trip occurrence over the year. And then at the bottom left, we have total daily trips versus forecast average temperatures in Fahrenheit. So the total trips are in blue, and the forecasted average temperature in Fahrenheit is in orange. And you can see that the number of trips kind of follows the same pattern as the temperature does. So when the temperature is warmer, people are looking like they take more trips. And then if you were to hover over a specific day, and that, as you can see in the middle picture on the right, you can see the exact number of total trips taken on that day and the forecasted average temperature. The bottom right graph shows the number of total trips by day of the week. So on average, how many trips were taken on that day out of the week over all the 3 years that this data covers, with one being Sunday and seven being Saturday. And so if you were to hover over one of these bar graphs, you could see the average number of total trips taken on that day over the years. And then moving on to our real-time dashboard, as you can see at the top, for the next 7 days, we can see the number of total predicted casual trips, total predicted member trips, and then adding them together, the predicted number of total trips happening over the next 7 days. And then you can also see the timestamp of the last data ingestion. So you can make sure that that's live and occurring on the day of. And so next we can cover predicted casual trips over the next 7 days and predicted member trips over the next 7 days. Both are in the form of a bar chart. Both are very similar in the sense that if you were to hover over one of the bars, you would see at the top right the predicted number of either member trips or casual trips to be taken on that day based on prior training of the model. And then at the bottom, we can see predicted total trips versus forecasted average temperatures in Fahrenheit. And the predicted total trips is in blue, and then the average temperature is in yellow. And also predicted total trips versus forecasted max wind speeds in miles per hour. And then if you were to hover over a specific day there, you could see on that day how many of the trips are predicted to be taken in total, and then also the forecasted average temperature or max wind speeds.
So now our business impact. There's three main business impacts we're considering. First one is improved fleet allocation and availability. We're going to be able to rebalance bikes across stations. For example, when there's clear weather, we're going to move bikes towards higher demand areas. In addition, there's going to be less stockouts. When there is high demand, we want to be able to have enough bikes for everyone. The second one is operational efficiency and cost reductions. We can optimize labor and logistics better. We can plan staffing routes and maintenance routes based on weather. This will reduce any unnecessary trips, which might cost gasoline, time, and extra money, and reduces overtime for the staff. Last, and maybe most important, is dynamic pricing opportunities. We can put in place surge pricing during high predicted demand, such as sunny weather. With more demand, we can charge them higher prices, and earn higher revenue. In addition, on the other hand, we can offer discounts and other incentives during low demand conditions.
So that's all for our presentation. We're going to move on to the demo and kind of show you end to end how everything works. And yeah.